Hey guys, welcome to the final video for nuclear chemistry. What we're going to look at is we are going to look at half-lives. When we talk about half-lives, we're talking about how long it takes for half of a sample to decay. This is usually how they determine how old something is. Even with human aging, they would use half-lives and use that chemistry to figure out how old something is. It's called carbon dating usually. There's also other sources that we can use for that. So, I'm going to show you how to do the problem, but you really need to know specifically what is a half-life. Okay? So, how long it takes for half of a sample to decay. What do I mean by this? I mean that here I have some chalk. Okay? I'm not going to break my chalk because I need my chalk to write. But here I have chalk. If it takes 500 years for half of this to decay or break apart into something else, something other than chalk, okay, something other than calcium carbonate, well, that would be, the half-life would be 500, okay? So, I guess I will break it. Okay, so that's 500 years for half of this to go away. So now we have this. What happens after another 500 years passes by? Well, half of this is going to go away. Some people would say that all of it would go away, but that's not true. Okay? You still have 25% left. 25%. Well, another half-life, another 500 years passes, and you have still product. It's going to get harder and harder for me to break. Okay? You still have some left. That was another 500 years. And you keep doing this. Another 500 years passes, and I'm getting rid of half of it. I'm making a mess. Okay, but you can still see, I still have some chalk, and this was after, in this case, 2,000 years. 2,000 years. So you can see how much I have now, and figure out, well, what does that mean? How old is the sample? Okay? You can keep breaking it, till you eventually almost have none. But guess what? You still have some. Okay? And you're always still going to have some that you can say, I can determine how old this is because what if I have 0.5% of the sample? It's just really, really old. Okay? So that's the purpose of half-life. Some things have a very short half-life. Milliseconds. Okay? Instantaneous. So it can go through a half-life before you even blink. It's already decayed into something else. Okay? Other things have a half-life of millions or billions of years. So that means they're going to be around for much longer than we're going to be around. So there's two different scales to that. What we're concerned about in terms of half-lives is typically the ones that are going to be around in terms of uranium, polonium, things that are radioactive and dangerous. We're still worried about that, okay? But other half-lives that happen instantly, usually we don't care about those, unless they give off harmful rays, obviously, which sometimes in terms of nuclear chemistry they will. So let's run some of these problems for you. You will have to draw a chart for all of them. Okay, and we're just going to look at number 1 on worksheet 2. Okay, so we're going to start with 400 atoms. 400 atoms, and I'm going to run through everything. I'm actually going to make up some stuff as well. It's not imperative that you write the stuff that I make up, but you'll just need it later. So, if we say that we have 400 atoms, okay? Try to figure out the best place to put this. Right where the light is not, hopefully. Okay? So, I'm just making a chart. I'm going to have percent. Okay, that's a percent symbol. I'm going to have grams of substance. So grams of substance. You can write out the whole thing. Okay? grams of substance. That's what that says, if you're curious. Okay? So percent grams of substance. We're going to write time passed. And that'll be it for now. Okay? That'll be it for now. We ran out of room in terms of the camera anyways. So, first thing we're going to do is we're going to start out, we have 100%. Okay? Pretend like the chalk that I broke. We started with 100%. Okay? So, if we look at the problem that we're looking at, we started with 400 grams. So that's going to be our 100%. Okay? How much time has passed? None. No time at all. We still have 100% of the material. No half-lives have passed. Okay? We're going to say that the half-life of what we're talking about is 500 years, because that's the example that we used earlier. So, if one half-life passes, we are left with 50%. 50%. What is 50% of 400? We're left with 200 grams. And how many years have passed? 500 years have passed. Okay? For these problems, you won't always, you aren't going to make up time passed. You will usually be given that information. If they say the half-life is 500, that's why it goes by 500s. If they say the half-life is 2 billion years, this would say 2 billion, 4 billion, etc., etc. So, percent left, okay? Now let's cut the half, 50% in half. What's half of 50%? 25%. Okay? What is half of 200? 100. Okay, so all I'm doing is I'm taking half, because it's half-life. Okay, if another half-life took place, okay, this would be 1,000 years. Okay, that'd be 1,000 years. What's half of 25? So, if I make a new column, see, I knew I was forgetting something, okay? This is number of half-lives. Number of half-lives. You can write the whole thing again. Number of half-lives. I just wrote T half. That means half-life. Okay? So, 0 half-lives took place. 1 half-life, 2 half-lives. On my third half-life that took place, what's half of 25? Well, 12.5. That's 12.5% is remaining. What is half of 100? That would be 50. How much time has passed on my third half-life? Okay, 2 different ways. 3 times 500 is 1,500, or just add another half-life. 1,500 years. Last one we'll do, on my fourth half-life. What percentage is left? You take half of 12.5, that's 6.25. Okay, how many grams is left? 50 divided by 2. It's going to be 25 grams. And how much time has passed? Another 500 years. 2,000 years. Okay? For all these problems, you will need to draw a chart. Okay? I want you to get in the habit of it because it's very, very useful for me to see. It's how I actually learned how to do half-lives. So I want you to get used to drawing a chart. Okay? There's quick ways to do it with that said. And I am going to tell you the quick ways to do it. Okay? But first thing, when you do the chart, have the number of half-lives. Start off at 0. Okay? And that will give you 100% of your sample. So this says percent. Start at 100. Always 100. Grams of sample. That will always be given in the problem. Okay? So if you start with 30 grams of the sample, start with 30 grams of the sample. You can always choose to start at 100 grams if you aren't given much information. Usually 100 grams is the go-to because it will usually match your percentage. Time passed, Um, obviously, if it's still at 100% and you have 0 half-lives, it's going to start at 0. Okay, your next number is going to be whatever 1 half-life is. Okay, so 2 different shortcuts that I want to show you. Okay, half-life percentage. Here's the first thing. Okay, if you have 3 half-lives, well, what's a really easy way of finding out what percentage is left after 3 half-lives? Half to the third. Okay, and this will tell you what percentage is left after 3 half-lives. Like I said, this is optional, but it's a good tidbit of information. So 1 divided by 2, you multiply those. You can punch in the calculator as well, and you'll get 1/8. 1 divided by 8, when you put in your calculator, is going to give you 0.125, which is 12.5%. Okay, make sure I multiply by 100. But that's 12.5%. Okay, so that's how you can determine what percentage is left after so many half-lives. If you want to know quickly how much time has passed, okay, how many years has passed with 3 half-lives, what's the quickest way to do that? Well, you have 3 half-lives times how long a half-life is, and that's going to be the time passed. So in this case, we know that the amount of time for 1 half-life is 500. You can't see that. 500 times 3, 1,500 years. If I want to know how long it's passed when we have 16 half-lives, 500 times 16 is 8,000 years. Okay? And if you want to know what percentage is left after 16 half-lives, since that's what we're doing, how would you do that? What percentage is left after 16 half-lives? 1/2 to the 16th power. Okay? I do not have that memorized. So, but plug that in your calculator, you'll get your answer. And that's it, and then multiply by 100. So it's a very small percentage that will be left. Okay? So, like I said, if you have questions, feel free to just ask me during class. That's what I'm here for. If you need to call me, you know my cell phone number. I'll leave it 513-939-5955. Please call me. Get some help with this material. Please, please, please. So, enjoy your day.